Well, as we begin this semester to look at all the different tools that are available in the shop, we will cover them, 3 or 4 or 5 of them a week until we complete the semester, and we'll have covered all of the tools in the shop. And we'll just do that week by week. And we'll start today by looking at the table saw. The table saw is a very simple tool, but it's actually the backbone of any woodworking shop in the world. Most projects start with the table saw. So we'll look at it first. Now the one that we have is a Delta 10-inch Unisaw. It has basic controls. You can control the height of the blade through this wheel in the front. The angle of the blade is controlled by the wheel on the side. You can angle the blade from 90 degrees to the tabletop to 45 degrees in one direction. There's a number of safety things that we will get into in just a moment, but I just wanted to cover the basics first. Now this particular saw also has a power disconnect on the back. Now this power disconnect allows you to completely disconnect the machine from the power, so it can't be turned on no matter what you do at the machine. And that stays off unless you're actually ready to operate the machine. Now once you're ready to turn the machine on, you have on-off switches in the front of the machine as well. Now the machine also includes the fence. Now this fence will slide back and forth, and then you can lock it in position. And this allows you to set the distance from the fence to the blade for the specific cut that you want to make. And you always use a fence when you're ripping lumber. When you rip a piece of wood, you're going with the grain. The other cut that you can make is called a cross cut, where you actually cut across the grain. Now to do that, it does require a miter gauge. Now the miter gauge goes in one of the 2 miter slots that you see on top of the table. And in these slots you can also put any number of jigs and fixtures. There's no shortage of them on the market, plus you can make your own that will fit a specific saw and accomplish a specific task. We have a number of them here in the shop that we use at different points for different things. But the important thing right now is that these miter slots are parallel to the blade, so that when you run the miter gauge through here, you can actually ensure that you're cutting perfectly square because you're going parallel to the blade. And we'll look at other features in the saw a little bit closer detail in just a moment. Okay, now it's time to talk a little bit about safety. There's a number of things that you need to pay very close attention to in operating a table saw, because this thing can hurt you in a number of different ways. The first thing we'll talk about is the actual height of the blade. Now you want that blade to extend just a little bit past your work. Now this is about 1 tooth height above the work. That's approximately 1/8 of an inch. And that's all you need for the blade to extend above the work to make a good cut. If you put additional height, if something goes wrong and you wind up getting your fingers too close to that blade, the extra blade height is simply going to increase the severity of the injury. So keep the blade as low as possible, and that's the safest way to do it. Now, One of the biggest dangers in a table saw is a kickback. Now, it's important that you understand the dynamics of a kickback. And a kickback is when you're running the board through the blade and something goes south, and the board that you're trying to cut is actually thrown back in this direction at almost 100 miles an hour. So if you happen to be in the way of a board that's traveling at 100 miles an hour, it almost guarantees that you're going to be injured in some fashion. The 100 miles an hour comes very simply. If you do the math, the blade is 10 inches in diameter. So if when it makes one revolution, that blade has turned a little bit more than 30 inches, almost 3 feet. And when you calculate the RPMs that it's turning, you can figure out the actual speed, the lineal speed across the top of that blade. And it's about 94 miles an hour. So kickbacks are a thing that you want to avoid at all cost. Now, kickbacks always occur from the back of the blade. You will never get a kickback from the side of the blade or from the front of the blade. Kickbacks always occur on the back of the blade. In the front of the blade, the teeth are going down. But at the back of the blade, the teeth are coming up. And if those teeth get a purchase on the piece of wood, they want to lift the wood and then move it forward at the same speed that it's turning. So to avoid a kickback, if you're ripping, which is where you get most kickbacks, you want that wood against that fence. And if you go through this at a good feed rate where it doesn't get off the fence, if the wood moves off the fence, either from the back or the front, it's going to jam the wood in the blade, and that's going to cause you a kickback. There are times when internal stress in the wood that was there when it was a tree want to close the kerf behind the blade, and that will add enough pressure to the blade at the back to give it enough purchase to lift the wood and move it forward at the same speed the blade's turning. So there's a lot of different causes of a kickback. The best defense against a kickback is to simply move over where you're not standing directly in front of the piece of wood. Stand to the side. So if there is a kickback, it will go by you and not into you. So that's your best bet for a kickback. Now, another tool that's extremely useful when you're doing rip cuts is called a fingerboard. Now, a fingerboard works very simply. There's a number of long, narrow slots, or fingers for that matter. Maybe that's why they call it a fingerboard. Now, a lot of them will fit into the miter gauge and you adjust them from there. But a number of them are magnetic. You can put them into position. When you turn the two knobs, it's now firmly attached to the tabletop. Now, to use it, you would put your board, you set your fence, of course, for the cut that you want to make. But then you can position this feather board, and when you position it, you put a little bit of pressure. So there's pressure on them, so you can see the fingers begin to move. And it forces the board against the fence. And that gives you extra support to keep your workpiece against the fence so you get a nice even cut. Now, the important thing is you do not place this past the blade, where the blade is going to cut. If you do, the extra pressure will try to close the kerf, and that will cause the blade to burn and increase the heat that you have to deal with. So you would never place a fingerboard past the blade. But it gives you a good way to control this, so as you're sliding that on through the blade, you don't have to be as concerned about your workpiece coming off the fence, because your fingers are applying pressure that keep it against the fence. And that's an excellent way to control a rip cut. One of the things that you need to be able to do when you're using a table saw on a longer piece, if you don't take precautions, by the time you run the piece all the way off the end of the blade, the piece is too heavy to support. So you need to use some kind of steady rest on the back side of the saw. So when you're making your cut and you run it through the blade, it will continue on out and it will engage the top of the steady rest, and now it's supported as you push it all the way through the end of the blade. And that's the only safe way to cut a piece that's longer than you could control with just the tabletop. Now, we spoke earlier in one of the segments about the fence. Now, the fence is the primary way that we control the depth of cut in a rip cut. We move the fence up to the distance that we want it from the blade. And there is a tape measure on the fence here. I don't recommend that you pay a lot of attention to that. The only way that you can be absolutely positive is to measure from the fence to the blade to know exactly how wide you're going to cut. Now, you'd set that to whatever width that you want and lock it down. And then you would simply slide your work through the blade while it's touching the fence. And you get a cut through your board that's exactly the width that you want. Now, if you're going to make a cross cut, then you would use a different tool. You would use a miter gauge. Now, the miter gauge goes into the miter slot, and now you can turn your board to where it's crossways, perpendicular to the blade. And now you would hold the piece against the miter gauge, and then you would simply slide that through the blade and make your cut. And now you have a 90-degree cut. Now you can change the angle on your miter gauge in either direction from 0 to 45. So you can cut angles with your miter gauge as well. But you would never use a miter gauge and a fence at the same time. You use one or the other. And as a general rule, you use your fence for rip cuts. That's a cut that's with the grain. You use a miter gauge to cut across the grain, which is called a cross cut. And that's the two basic operations with a table saw. You're either ripping with the fence or you're cross cutting with a miter gauge. Now that pretty much covers the major safety concerns. There will be a lot more that's covered once you're able to be in the class and be in front of the saw in person. But the big thing when you're done, when you've finished making your cuts, you always want to take that blade and put it back down all the way, and then go around and turn off the main power. So you leave it in a position where nobody can get hurt on it by assuming that the power is turned off. When you walk away from a saw, you put the blade down and you turn off the main power. And then the saw is completely safe. Now we have a second table saw in the shop. It's a little bit different from the Delta. This is a saw stop. It's basically the same saw. It has a 10-inch blade, exactly the same as the Delta. It has the same basic controls. There's a wheel on the front that controls the height of the blade. There's another wheel on the side that controls the angle on the blade. And it also goes from 90 degrees to 45 degrees to the table in one direction. To energize this saw, it's a little bit different. The main disconnect is different. You'll see the disconnect switch on the side of the saw. And because it's mostly electronic on the inside, the actual procedure for turning it on is different. Once you turn on the main disconnect switch on the side of the machine, the lights will begin to blink. And once it stops blinking and it turns green, now it's ready to operate once you turn the switch here on. So you would turn this switch on, the lights would begin to blink. When it goes to a steady green, you're ready to operate the saw. Now, when you're actually ready to make a cut, if you lift this large red paddle, it will start the saw. And the same way, when you're ready to turn the saw off, you just hit the big red paddle and it will turn the machine off and the blade will stop. You would never turn the saw off between cuts using the on-off switch here. This one you only use to turn the machine on to begin with, to energize it to begin with. The actual on-off function is controlled by the large red paddle. Now, the big claim to fame of the SawStop is it's supposed to be much safer, because if you do happen to get your finger in contact with that blade, there is an electronic sensor mechanism inside it that will trigger almost instantaneously, and it will throw a big piece of aluminum into the blade, which will stop it in nanoseconds. Most people that get their finger too close to that blade and it engages the cartridge, they generally only receive a very superficial cut rather than losing the entire digit. So we have that, and we have that protection. It shouldn't be taken for granted. The fact that the machine has that electronic sensor should make no difference in how you operate the saw, which is primarily to keep your fingers off that blade on purpose. Don't count on the saw to make up for a stupid move. It's just not smart. So you would use exactly the same caution on the SawStop as you would on any other table saw that doesn't have that electronic sensor. But other than that, the saw operates exactly the same way as the Delta, so everything I talked about with the Delta applies to this machine as well.